Hello, everyone, and welcome back to class. I'm so excited to see you joining us this week. Last week, we talked about rocks, and the week before that, minerals. And now we are going to get further into understanding the geosphere in the broadest sense. This week, we are going to be talking about a unifying theory that was based off of a concept and can be physically observed using technology. This theory is an idea that when you walk away from this class, I want you to think about this as the primary example of our dynamic geosphere. Do you know what idea we're going to cover? That concept or idea is the theory of plate tectonics. Now, what is plate tectonics, you might ask? Well, it's just a way for us to conceptually understand that our continents on the planet and the seafloor are always in motion. During my academic training of being a paleontologist, I actually pursued geography. In fact, I used geographic information systems, basically computer programming, in my research to understand how the landscape may have looked at different periods of time and what plants and animals can be found. That's actually a subset or subdiscipline within geography. That's going to be biogeography. But how I got interested was when I was little, I would read National Geographic magazine a lot. And within National Geographic magazine, they had wonderful maps. So this week's unit, we are going to utilize lots of different maps. Here's a good example of a map that I was just looking at right here. This map is the Upper Jennings Run watershed found throughout Allegheny County and how to implement it. So it actually connects into our running and groundwater unit later in the course. But maps are great because they can take a concept and put it into a physical context, much like how we're going to do it here in the plate tectonics unit. Let's take a look at this globe. A globe is just a physical representation of a map. Only it's, circular shape. Many classroom maps use what they call a Mercator projection, which allows you to put it on the wall, and then it actually has units of measurement that don't compensate for an actual perspective. It compensates more for distance rather than perspective. There's entire research articles and other popular examples that show that the Mercator map that you may have encountered in high school, middle school, and in several mapping books in your day-to-day lives is actually relatively incorrect. But that's not our goal in this class. Our goal is to talk about plate tectonics. And you'll take a look, say, Africa and South America. In a modern context, these two are relatively spread far apart. You have an entire ocean basin between the two. But using some of Alfred Wegener's concepts as part of his theory in plate tectonics, we can actually go and combine them together. And this is one line of evidence that we'll talk about in lecture, the apparent fit of the continents. We will also examine other lines of evidence, such as the distribution of climates and the plants and animals. We can even take a look at the succession of the rock record. Little known fact that there are sections of the Appalachian Mountain Range that surrounds our campus that is connected and correlates to units found in North Africa, but also Europe. In lecture, we're going to focus mostly on lines of evidence dealing with plate tectonics. We're going to use products like Google Earth, so that way you can be able to visualize the interactions between, say, divergent plate boundaries, convergent plate boundaries, and even those that transform and eventually produce earthquakes. In lab, we're going to set sail on the open seas. We're going to look at data collected by oceanic institutes to be able to understand that there are lots more lines of evidence that work very well with Wagner's concepts. And more data means that science will constantly change, especially this topic of plate tectonics, but the theory still sustains. It stands the test of time. That's important for being able to take a concept and convert it into a physical model, so that way we can communicate it. But, all right, if you have any questions or need some help, I have prepared tutorials on how to use Google Earth and how to install the program. I've also have a recording on this week's topic and some really good supplementary information for you to read. If you have any questions, again, please reach out, either in person, through email, or on Zoom. Thank you and have an excellent day on planet Earth.